Yo, welcome to my non-live stream. Thank you for joining me. So we're gonna mess around here, and I just turned the camera on because let's see what happens. So let's get you up to speed. First off is right now I was running the Gumol Viz engine, which is basically a molecular dynamics visualization engine that I wrote in Rust, but I use Bevy. Bevy is a game engine. They use an ECS system for Rust development. And I figured, hey, you know what? I'm going to use some of those features and I'm going to build this to be molecular dynamics visualization engine. So the first part about it is, here, let me move this lab coat so it doesn't look like a ghost in the corner. Anyway, the first part about it is, yeah, I kind of optimized it for .xyz files, which is like 3 coordinates in space, and PDB files. So, and it all works, but it has a lot of latency, so it's slow. And it's slow because it's not efficiently using the GPU for all the rendering. So, what I do now is, let's see if I can show you. I'm going to pop over here, and you see this agent that's kind of like running here. Close your eyes so you don't get sick. Anyway, this is me testing it. Come on. Spawning. Anyway, here we are. So I built this, it's called Vybrid. It's an AI coding assistant built in Rust for Rust development. So when I get tired and lazy of like reviewing the code, and because it's running slow, and I just wanted, okay, so it came through here. I wanted Vybrid to go through and review the project and then tell me about what's the issue on the latency, and let's see if Vybrid did a good job. All right, so we said they completed a comprehensive GPU performance analysis of the Gumol Viz engine. The project has a fundamental GPU efficiency issues that prevent it from running the PDB XYZ files smoothly. Let's see. So the current one is each app spawns at a separate entity with its own draw call. Okay, so Bevy is the ECS, so it's entity component. I think S is system, ECS. So each that spawns, right? So it'd be like a single atom spawning like a player in a game, and then the impact is 10,000 atoms equals 10,000 draw calls per frame, so 10 FPS. Group atoms by element and use instance rendering. 10,000 atoms equals 118 draw calls equals 200 plus frames per second. I'm not sure if I'm down for that though. I might have to do some math. Okay, the other one is CPU-based position updates. The timeline interpolation done on CPU positions upload to the GPU every frame. PCIe bottleneck, CPU wastage, and 10 milliseconds per frame overhead. Use the GPUs to compute shaders for interpolation. Yeah, obviously, that's what I want to do. That's why I asked you. And that will reduce the CPU load. Okay, so this right here is valid. Async or synchronous file loading. Yeah, the async with the Tokyo library. Tokyo, progress file. Okay. And I'm just going to kind of scan down here. All right, so we got performance comparisons. UI freeze. Yeah, that's the problem. It's kind of latency. All right. So it's created this document. Okay. And then testing. And then threw down some researches. Okay, your project has excellent features. Parsing timeline selection bonds. Okay, obviously. Fix the 3 critical issues. Okay, the only one that I see perhaps would be like not good is this first one. So 10,000 atoms equals 10,000 draw calls per frame. So 10,000 calls per 10 FPS equals 10 frames per second. Group atoms by element, 118 elements max, and use instance rendering. Okay, I guess the other part is that that wouldn't be, because this is what we're ultimately trying to look at, like 10,000 atoms simulation in a run running at 60 plus FPS. Like that's what we're trying to get to. That would be ideal in my mind. Okay, so to get started, read. Okay, so let's just start building it. Okay, so basically, because I'm lazy and I don't want to look through it, I guess I should a little bit. Okay, so rendering mod.rs. All right, let's get to the rendering. Okay, this mod.rs. Let's go back this one. Okay, add to, okay, so this is a shader type, a shader reference, and a buffer usage. All right. Okay, so first it's rendering. Now, where though? Okay, so I just want to change this construct for, is that what it is you're asking for? Okay, so we're going to render resources, render device, core, cast slice. Okay, so yeah, I'm just going to add that. Okay, that's cool. We'll see that then. Okay, let's check out this other one. Modify from spawning. So we're going to pop into the spawning, camera, core, expert, interaction. What is this one? Oh, sorry. Systems. Spawning is under systems. All right, so we got our systems here. We got our spawning. And then let's check this out. Let's go back here. Okay, spawning items from internal. And we got the asset. Get position from the atom ID, the entry. Okay, so then they're going to push the atom info. Okay, that makes sense to me. Now, where... Let's get down to systems, and spawning. Okay, so they just need to push the atom data or the atom info. That's what's being added. Okay, I'm cool with that. All right, let's just rock it. Okay, we'll debug it on the back end. What's the problem here with the visualizations though? Yeah, well, this would not be, this would be a float, like a float 32, not a, okay, dot clamp. Not sure. I'm supposed to find a concrete type of this numeric value, like float 32 or 0.05 underscore float 32. So like, yeah, okay, I think I'm down for that. Let's, okay, we're gonna fucking leave it like that. Not sure. We'll have to come back and fix it in later. But for now, let's kick this off. And again, because we're lazy, man, so this chat and be like, all right, so we got 2 agents rocking, and that's like the agent developer. I know this is wrong, but I know there's a few different ways to fix it, which is like adding the flow32 on the back end, probably even getting rid of the clamp, or you can set it as a flow32 and then set that variable. Yeah, see, like exactly how I had it. Do you see this where it's like the flow 32 for the clamp? That's how I had it. So I wasn't completely off taste, even if I didn't like read that tool for context. Anyway, let's see, how many minutes is this gone? Oh, it's 15 minutes already? All right, let's check this out. Let's see where we're at. All right, so there's an update there, and I think that's it. So thanks for joining the non-live stream. Someday I'll get this live stream thing open, but just about this project. Again, this is Gumol Viz engine, so it's like running really slow, which means it's not efficiently using the GPU for work, but it will. So